So Dr. Jingqiu Mao is a HAQAST member from University of Alaska Fairbanks. So please go ahead, Jingqiu.
Okay, so first of all, thanks everyone for attending this talk. So basically, let me just start with introducing my team with questions in my group, Kenan Zhao and Ziwei Dong, and Martin Stufer, who is a co-PI on the proposal. Also, Jesse Zhang and Jun Wang from University of Iowa, and Hire from Naval Research Laboratory. Our main focus here is on wildfire in Alaska, and we have a bunch of stakeholders, including DEC, AICC. There are a lot of agencies involved on this, trying to understand how wildfire impact air quality in Alaska. So let me just start to introduce you that how large Alaska is. That if we look at the left panel of this slide, that you can see Alaska area is almost 1/5 the size of entire lower 48, and it's larger than California, Texas, and Montana combined. So it's very large, and the burning area on the right side, you can see that sometimes it can be over 5 million acres burning area per year. So it can count a major fraction of burning areas in the United States. This has been understudied, and it's also quite important both for air quality and the climate change. And one thing I want to mention is that the boreal forest fire is kind of very unique, that 60 to 90% of fuel combustion comes from carbon in boreal soils like peat, duff burning, and the mean is smoldering. This on the picture on the left is actually a picture I took when I was flying on NASA. I was flying NASA DC-8, and the colleague who took this picture, and you can see mean smoldering. And this actually poses a quite challenging for satellite fire detection due to low intensity fires. From a paper published by a colleague of mine who finds that 45% of fire undetected by satellite. And this also can lead to underestimation of aerosol emissions in current emission. Hold on, give me a second. Okay, here we go. So can lead to quite a bit of aerosol emission. Current emission inventories mainly derived from satellites. As you can see from the right panel here, model PM2.5, this was simulated by GLSCAM model, is often too low by factor of 6 for year of 2015. There could be other issues there too, but it's also could be due to the underestimate of wildfire emissions. So so we have done two projects on two sub-projects for this our HAQAST team. One is that we're trying to estimate surface PM2.5 in Alaska summer using polar orbiting satellites. So our main idea is that we like to understand the air quality in rural Alaska and indigenous communities where they do not really have much measurements, ground-based measurements, and but it's not quite as easy as we thought. So there's a lot of challenges. And first of all, let me just show you the map of Alaska. Here is actually, there are two main ranges. One is Brooks Range on the north, and one is Alaska Range on the south. And the main boreal forest fire is inside this range, and sometimes we also get lots of wildfire smoke coming from Siberia. So so the main challenges, one is ground-based measurement is sparse, and they're also very complex topography, and we also have intercontinental transport, and we do not have any model evaluation. So we just don't know how good the model behaves, and that's also one of the motivation for our study. So our method for this study is that, first of all, here I'm showing you, this is a workflow done by my grad student. And we first of all, we use AeroNet AOD, which in a couple of sites, there are a few locations available in Alaska. Use that to crack MODIS and the WIRS satellite WIRS MODIS and the WIRS AOD. And then we also use a nasty grid GLSCAM model to develop an AOD PM2.5 relationship. But we found this relationship was kind of way too high due to a number of reasons. And then we decided to crack that relationship using the long-term observations in Alaska at few sites, very few like there's two sites. We developed a relationship based on satellite AOD in the past 20 years with the ground-based measurements for two sites. Then we use that relationship to crack model. And then from there, we develop corrected model AOD and PM 2.5 relationship. And then we use this corrected relationship to derive satellite AOD, to derive satellite PM 2.5, satellite-based PM 2.5. And then we use that to compare peripheral air sensors as well as ground-based measurements. So this kind of workflow of ours. And I'm just going to show you quickly here how the results look like. If you look at on the right side, that this was AOD in the summer of 2019. In July, we had lots of wildfires. For example, AOD went up to like AOD 2 to 3-ish. And then we developed a relationship on the second row of the panel here. The model developed GeoScam relationship was kind of too high, almost to 200. We found that it was just much higher compared to observations. Then we used observation to do a correction for this relationship. This was kind of corrected slopes for with observations, and then we use this slope to derive satellite derived surface PM 2.5. And here you can see the bottom row is the derived surface PM 2.5 for summer of 2019. So this was idea, and it's still is kind of in development, in progress right now, because it's not as good as we like, and we still like refine this approach a little bit. But results do show some does show some promising results here. That here we compare air now, we find that our derived surface PM 2.5 agrees reasonably well with air now size as well. Prepare we do not really try to prepare 100%. So but we do find that overall R square is pretty good for some sites. And this is just something in progress. Another part of the work I like to introduce is this is mainly led by Jesse Zhang and Jun Wang from University of Iowa. This is kind of multi-modal, multi-AOD ensemble bias correction approach. So they use GeoScam model and the WarpCam and CMAC models as well as 3 satellite to trying to seek synergy between surface observation network and satellite observations. They're trying to provide a computational fast and economic method that has the potential to be used by local air quality agencies. So they have 2 papers published on this type of the first paper, which was published in 2020, that use model output and surface observations to improve surface PM 2.5 forecast for places that have a ground observation within 125 kilometer radius from ground observations for those non-rural area. And then recently they published a paper to integrate model surface and satellite observation to improve PM 2.5 forecast for rural areas, which is 125 to 300 kilometers away from ground-based measurements. So with these 2 parts, that they really can develop a really nice way to forecast PM 2.5 for locations that are even further away from 125 kilometers, somewhere between 125 to 300 kilometers. Basically, they use ensemble satellite AOD and doing bias corrections through AOD to find the best PM 2.5 for today, and use common filter to update bias and the forecast surface PM 2.5 mass concentration for next day. So this has been published, and we currently, I just want to show one quick results before. So one quick result here is that this approach, common filter bias correction, PM 2.5, shows the most promising results in the lower rightmost panel here. That is basically this ensemble common filter that has the smallest RMSE and the mean bias. So overall, this ensemble common filter bias correct PM 2.5 shows the best performance, and this is something we are going to use for Alaska. This actually, if you look at, if you read this paper, this has mainly done for lower 48. And right now, we're going to apply this approach for Alaska for next year to see how that works. Again, because due to the very sparse measurements, this approach may really have some advantage to to do some to have good performance over somewhere there's basically have no measurements. So it seems like it's really promising way to do this. So these are 2 projects we have. That's all I have for now. I hope any questions or.
Great. Thank you so much, Jingqiu. We're actually going to hold questions until all 4 speakers have gone. And so if you do have questions, feel free, as you're thinking of them, to put them in the Q&A or the chat, and we'll be making sure to moderate those in our discussion session. At this time, we'll move straight on to Jeff Pierce, who is another HAQAST PI from Colorado State University.
Sorry to remember how to unmute myself when sharing my screen. All right, so I'm going to talk about combined Earth observations for smoke exposure and health studies. So I'm going to talk about what my team is doing and a lot of our collaborations and how our smoke is being applied. And so I specifically want to call out Bonnie Ford, Emily Fisher, Cheryl Magzaman, the core team here at CSU. And then we have many collaborators that are going to be highlighted on slides through some of the publications I'm showing and ongoing collaborations. All right, so I'm showing this, like similar to what Jingqiu just showed, this really complicated image of smoke seen from space, and you can see that the concentrations vary a lot. Fires are these hotspots, they're shown everywhere. And for the many reasons, we need to understand when and where smoke is present, as well as how much smoke is present and the composition of that smoke at the surface. We need to understand this to try to understand what the health and welfare effects of smoke are through epidemiology or toxicology. We need it to understand what the burden of diseases, like how many total asthma hospitalizations in a year are contributed to because of smoke. We need it to understand what populations are most vulnerable to smoke. We need it for air quality regulation, exceptional events. I think we're going to hear about this later from our stakeholders speaking later. We need it in order to have good communications and messaging from various communities and health and air quality agencies. We need it for community planning, and we need it for our own personal choices. Are we going to stay home or are we going to change our exercise? And so it's with these different sort of end goals that we go into trying to understand how can we understand where, when, and how much smoke is present. So quantifying smoke exposure is a big challenge. So first we have this vertical gradient. So this is a photo taken of the Cameron Peak fire by a former student of mine who was driving near Fort Collins. And it's very clear from this image that he's underneath the smoke. It's not at the surface. So if you saw this from space, it would look like smoke was there, but then Alec, the student, wasn't actually breathing it. So it's challenging to know whether it's at the surface or not. Often there's a very sharp plume edge. And so when Cameron Peak fire was affecting Fort Collins, there were times where the north half of the city was getting 100 grams per meter cubed, and the south part of the city wasn't getting any smoke from the fire. And so it often, if you have a city that has one monitor, it might not represent the whole city in terms of what people are breathing. As well, it can chemically evolve when the composition of the smoke can change. So we have 3
Jeff, I'm sorry to interrupt. We have a request, and it's happening for me too. Your audio is very choppy. We're wondering if you turn your video off, if that will help with the quality of the audio.
Okay, let me just see.
Sorry, thanks.
I don't know if it will. I think sometimes it happens with Zoom. Is it any better?
Actually, it sounds the same to me.
Okay, I don't think it's the video.
Yep.
Hopefully it'll clear itself up. I feel like this happens like once a month. Sorry. I will do my best. Hopefully this will work. We have 3 imperfect methods for determining smoke exposure. So you can simulate smoke with chemical transform models. It's going to tell you everything you need to know, but it's not going to be right, or very likely there's going to be issues with it. It'll tell you exactly what the concentrations are. It just won't be right. Of course, this is NASA, so we want to bring satellites. They can give you a very good picture of where satellites are in terms of where smoke is in terms of latitude and longitude, particularly during the day. But it doesn't necessarily tell you whether it's at the surface or not. There are some exceptions to this, but for most of the satellite data products, it doesn't tell you whether it's at the surface. And then we have surface monitors, and particularly regulatory monitors are quite sparse.
We have a growing network of low-cost monitors that might be helpful, but we're still just starting to bring these in and understand how we can use these best. So we take these 3 different methods. Can we bring them together to give accredited surfaces of smoke concentrations or PM2.5 concentration that we have some confidence in? So what my group and my collaborators have developed is a daily smoke PM2.5 product that extends from 2006 through 2020. We plan to extend this and we plan to improve it. This is just showing one day from August 2015, where we're showing this, our observationally based mixing satellites and monitors smoke PM2.5 is. So we can then use this for epidemiological studies. And so this is an example where Sara and her postdoc Ryan Gann used this to understand the association of smoke with hospitalizations in Oregon. And they see very strong associations with asthma, both with inhaled refills and hospitalizations. So this graph means this odds ratio that for every 10 micrograms per meter cubed of smoke PM2.5, the asthma hospitalizations went up by 10%. And so this combines if you have higher and higher smoke concentrations, you end up having more and more smoke hospitalizations. And they did not see a statistically significant association with pneumonia on this study. We also have worked with different collaborators to look at the association of smoke with mortality, ICU admissions, pregnancy outcomes, and even crime, finding that domestic violence has a strong association with smoke and PM2.5 in general. So we have this long-term product going from 26 to 2020. So we can actually do this to start understanding the burden of disease associated with smoke using existing epidemiological studies. And so this is just showing the average smoke concentration, annual average over a 16-year period. So the epicenter here in the Idaho, Montana area, Pacific Northwest, Northern California, but non-trivial amounts of smoke PM2.5 extending into the east. And one thing we find with this, when we look at absolute numbers of the health burden, even though the smoke is most concentrated in the west, as you'd expect, the biggest amount of the health burden comes in the east. So if you look at this map, the pastel easterly colors represent the eastern US, and the darker colors represent the western US. And this is just a time series of Odell's estimated asthma hospitalizations attributable to smoke. And there's a lot of intra-annual variability. There's intra-annual variability in terms of where it occurs and how much, but overall, these pastel colors tend to dominate. And this is just simply because there's more people in the east. But what it means in terms of health burden is that even though people tend to think about smoke most in the west, the transport of that smoke to the east, or the smoke generated in the east, particularly the southeast, really causes non-trivial amounts of burden of disease within the United States. So another thing we're thinking about is everybody's wearing masks now. We have different kinds of masks. We're wearing for COVID, and there's certainly a burnout with masks, but there is now an opportunity there is can people more easily protect themselves from wildfire smoke due to the availability of these masks. And so this is just showing the filtration efficiency, meaning what fraction of the PM do you have to remove from different types of masks, assuming that mask is well fitting. For N95 masks, natural masks meaning cotton, and surgical synthetic materials. Certainly, as we all know, N95 is the best in this, around 1 across all sizes, and wildfire smoke tends to be in the size range here between 0.1 and 1. So we could apply this and say, what if some fraction of the population wore these masks for some fraction of the time? How much would the burden of disease be reduced? And so Jack Kodros looked at this and did all these different scenarios that cause the uncertainty here. We were like, there's uncertainty in what fraction of people might adopt masks. How good fitting are they? What fraction of the day? Well, we can come up with some range of estimates of how much we might reduce the health burden. And of course, N95, as you might expect, will take up the most of those smoke particles. And based on what we think are some realistic range of scenarios, we might expect the burden of disease, in this case, hospital admissions, to decrease by on the order of 30% if people adopted these sort of our maximum scenarios. And this is all sort of based on this combined Earth observations approach to doing it. The next thing we looked at is we took our observation constrained smoke estimates, as well as having indoor purple air monitors, these low-cost monitors. Many people are putting them outdoors, but many people have them in their homes. And we wanted to see for different regions where there's a lot of monitors that has had a lot of smoke, how different are the concentrations indoors during smoke events compared to outdoors. And so just showing, I'll start with this. Yeah, this next slide. Yeah, I just want to show this. And so what this is showing on the x-axis here are different outdoor concentrations. They're grouped by AQI level. So this is like a purple AQI group down to the cleaner group. This is just during smoky conditions though. And this is the ratio of the indoor PM2.5 for locations that have those indoor monitors to outdoor. And as you can see, when the smoke concentration is high, I'll wrap it up soon. When smoke concentrations are low, there's a little bit of protective effect, but by the time you get to really smoky conditions, it's about 5 times cleaner on average indoors. Of course, these are homes of people who have bought purple air monitors. They probably care about their indoor air quality, so they may be taking steps. We don't know exactly what they're doing. But at least this shows the picture that staying indoors on average for these homes is helpful. I want to give a plug for agricultural smoke, that next session 3B. There's a campaign we have coming led by Cheryl Magsamen and Amber Soya. And this is just showing going from noon till sundown in March 2021. A very typical day. This is from Goes East. This is just smoke building up in eastern Kansas and Missouri, just showing how strong the smoke can get in these regions and why it's important for us to study it. And it has a very strong diurnal cycle. And finally, we're just working with local communities here to build better smoke communication tools using our satellite and surface-based observation knowledge. And yeah, thanks for having me speak, and it's great to be here with you.
Thank you so much, Jeff. And thanks to everyone, including you, Jeff, for bearing with our audio issues. Hopefully, I mean, I was able to understand, the majority of your talk. It just cut out a little bit here and there. So hopefully everybody got most of it. Thank you. And so we're going to move to our next speaker, and I'll just encourage everybody to keep putting questions in the Q&A or the chat as they occur to you. So our next speaker is Tom Moore from the Western States Air Resources Council and the Western Regional Air Partnership. Please go ahead, Tom.
All right. Thank you, Arlene. Pleasure to be on with everyone. Jeff and I may run into each other at the coffee shop more than we ever would at work, but I'm going to switch gears a little bit and talk about the application of data for kind of planning purposes and regulatory tracking. This has to do with the 2021 Western wildfire season of smoke and the beginnings of a air quality assessment. I'd like to acknowledge that Sara is a part of this, and I see names, a number of people on the meeting who are also joining us. So I guess I have to click like that. So during the 2021 season that we just finished, numerous sites were exceeded both the PM and ozone air quality standards. And a typical remedy historically has been to do analyses that are demonstrations of exceptional events. And the idea is that those data are flagged for regulatory purposes, and they have to be significant from a regulatory point of view. They prevent a existing non-attainment area from being bumped up to a more serious category or more stringent category, and or they may prevent a area from going into non-attainment or prevent backsliding for an area that's demonstrated compliance with the air quality standards. So very much framed up around compliance with the National Ambient Air Quality Standards. So I have a couple of slides borrowing from from Dan Jaffe. I think these explain a lot of information, and Dan is an expert who's been helping us think about some of these topics. You can see the differences, the thousands of monitor days or site days where PM 2.5 or ozone standards, the current standards, were exceeded. These are highly dominated by California, given the amount of activity, but as Jeff pointed out, a lot of the smoke transports from the west to the east and stops along the way, might be a way to say it. So some significant interannual variability. 2019, not so much of an fire season in the West in terms of the smoke impacts on air quality measurements, but boy, it was back in 20 and again in 21. So another thing that Dan prepared that I think is quite instructive is the relationship between what we call the regulatory inventories, the national inventories that the states and local agencies contribute data to EPA, and EPA compiles it. And these are just loosely grouped in terms of summarizing the comparison between what you could call industrial emissions, so power plants and other industry for PM 2.5 versus the interannual magnitude and variation in wildfire emissions. So you see this sawtooth pattern where you have down years, and of course this is showing you a large region of the country, even bigger than Alaska, and how that it's certainly the local effects or local emissions rates are different from year to year. Dan did use the Western area burned data to scale the 2017 data to produce the wildfire estimates of emissions there for 18, 19, and 20. So let's talk a little bit about exceptional events and how the 2021 wildfire season might fit into that program. So those demonstrations require a determination of which air data were affected, the sites and the days impacted, and our members, the states, locals, and tribes in the Western U.S. Are concerned about that, given the workload and other issues that I'll talk briefly about. And then we did hold a meeting to let folks lay out what they knew as of late September. We talked about how these wildfire impacts might play into the exceptional event program, but the fire season, of course, was still active at that point. So we asked the members to, talk about a few topics: the likely number of days, what the state or local agency might do in terms of submitting demonstrations, what the staffing and resource issues were, and what additional tools, might be helpful for this purpose. So we had a great turnout from the West in terms of states, locals, and a few tribes. That it was really necessary to explain these impacts. In other words, you're flagging data that was of poor air quality. So the issue is still there, even if you flag them for regulatory purposes. It's a workload management, and we're seeing both ozone and PM issues at the monitoring sites, but it's really dominated by PM. So there's some sort of subtle topics here: regulatory significance, flagging, the limitations on resources, and then looking ahead, the review of the PM and ozone NACs, which is underway right now, and whether these 2021 data might be even more significant, so to speak, in a year or two. So we collected some data from our members. We're in the process of doing that, listed there. We're still awaiting some additional feedback from OAQPS, and we're going to be scoping out some needed technical analysis support. So this is a slow moving cumulative area burned map from the National Interagency Fire Center for the 11-year period 2010 through 2020. And as you can see, there are really large areas that accumulate over a decade at a time in terms of area burned. So there were smoke emissions during all these times in and around non-attainment areas, as well as our class 1 areas that are protected by the regional haze program. So quite a significant thing there. And then this really is an important graphic, I think, because it explains that this is a Western US problem. The contiguous Western states, Montana down to New Mexico, are where the wildfires occurring in the US. There are years where it's very significant in Alaska, but once you move, east of the central plain states, the amount of activity is really quite low, and so as an exceptional events issue, probably not so significant. So here's a map depiction of the reports we've received so far. We have other reports in process from Montana and some other states. So we're still gathering data. Here's an initial summary of those data. 1,200 odd ozone site days, about 70 PM10 days were reported, and almost 1,700 PM2.5 site days. So this is obviously a temporal, long-term temporal issue during 2021. It's not a series of discrete events. And also it's geographically quite large. So we're going to collect additional data for October and November. This is a kind of a cartoon of some initial analysis of the GOES data, where we've flagged the fire detections and what they're telling us. And then we can also map the flagged PM2.5 exceedances and ozone exceedances. And then, we need to bore into this and do some more analysis. One of the challenges with the air quality system for monitoring data is that you have to have a certain amount of data captured on a given sample day in order for it to be valid. And until the states validate those data at the end of the first quarter of this year, so that we have a complete record for 2021, we won't know which ones are valid or invalid. So kind of headed towards wrapping up here. We don't have reporting from some states, and of course there may have been additional impacts. We're going to go back to the air quality system once the Q4 data are finalized. That allows us to augment data that states and locals have already reported, and also cross-check what flagging the states and locals have inserted. We're obviously starting on some maps and animations, and we need to scope out whether some kind of regional analysis support would be helpful to finish our work. And I just thought I'd do a little bit of an ad here. My colleague Jay Baker and of course my boss Mary Ewell are integral to this process. We're working as an association to help do what our members are asking us to do. So you could contact either Jay or me about this project. And we just finished our hybrid meeting in December, and had a series, I think, of interesting and informative talks that are listed below that you can access at that interactive agenda link. So hopefully this gives a little perspective on some of the efforts that are needed from and the size and scope of things that are affected from the Western wildfire impacts in 2021. So I'll wrap up there. Arlene, thank you.
Thank you so much, Tom. This was really great to get this overview of the different aspects. Anyways, I'll hold off till discussion. And at this point, in the interest of time, we'll move straight on to Sara Strachan from Idaho Department of Environmental Quality. So go ahead, Sara, and take it away. Thank you.
Okay. Hello, and thanks, Tom, for that. I'm going to talk about a few of the same things just from Idaho's perspective. Present here. Okay. So I'm Sara Strachan. I work for Technical Services at Idaho DEQ since 2004. I mainly do GIS and remote sensing for the air quality program. We've had a wildfire response at Idaho DEQ since about 2012, or at least an organized response. Wildfire season is a big deal. It happens every year. It's nothing out of the ordinary. So we've developed a smoke event response protocol that we follow. So it lays out what types of interagency coordination we do, key actions that we take and other agencies take, and also air quality triggers. So like you know, what it has to be, AQI has to be orange at multiple monitors for a couple days before we start springing into action and starting the whole seasonal activities. In terms of our products or actions that we produce throughout the season, we do a lot of forecasting of both air quality for all our regional districts, and we also, our meteorologists produce smoke outlooks and fire weather analysis every day. We also do lots of outreach, interagency conference calls. We have a smoke blog, and we interact with the media quite a bit during the season. I am more involved in the technical decision support, and that's supporting our regional and state office forecasters and people who have to interact with the public. And so I use the satellite data to help this decision support, and the main product is called the Idaho Wildfire Smoke Portal, which I won't be able to show you much, but it's linked in the PowerPoint so you can look at it later. This has been available for a few years. There's all sorts of information in here, dashboards. I don't know why it's doing that. There's imagery from morning and afternoon, MODIS imagery, links to GOES imagery, weather. I bring in near real-time AOD, aerosol index information. It's not going to load now because it was last, oh, well, it looks like some of it did. Let me just see if it logged me out. Well, that's not working. Okay. And then there's also lots of information about air quality monitors and forecast models. Okay, so back to this. So you can see from this usage chart, this is from 2021. So you can see that our season got going on July 5th and ended, or at least our response ended on September 24th. And this is pretty typical. I mean, I think it started a little bit earlier this year. Usually it's mid-July, but we had a very hot June. So, you know, it's usually, we get pretty good usage, and you can see there's different, it'll spike, usage will spike during major episodes. Like you can see one here in early to mid-August, and then one in later August, and then it drops down once things quiet down in September. Last year, I also rolled out a version 2 of this smoke portal. I just did it because I used a slightly different type of technology that loads quicker, and I was able to link to a lot more different sites. So like ARA, outlooks for situational awareness, just bring in all like different situational awareness apps and maps. Because there's been a proliferation of these types of sites since I started the original website. So I just thought I'd bring them all together, and then people can pick and choose which ones they are most useful to them. Okay, and so you can see I didn't release this one. I didn't get it completed till August, so it was sort of halfway through the season, and you can see it really didn't catch on. So you know, I'm not getting rid of the original one yet, and we'll just see if maybe next season this one takes off a bit more. But those are the two main products that I help provide satellite data for our forecasters. Okay, so just a little bit about smoke season in Idaho. I'm gonna again show you another website, and I'm not linking to this because it's not quite done, but I'm just trying to compile information, both historical information and current year wildfire statistics. So our last year in 21 was sort of an average year, a little over 400,000 acres burned, slightly more human-caused fires. So this is pretty normal. And let me just remember what else I wanted to show on here. Oh, in the air quality chart. Let's see. So these are a number of days during the wildfire season in each of the air quality categories. So, you know, a significant amount in orange, a few in red, depending on location. This is pretty typical. And this chart, the 2020 these are time series of all our PM 2.5 monitors in the state from July through September. I know it looks pretty messy, but it just gives you an idea of how, say if you look in early August here, there's always episodes that affect the entire state, like all the monitors at once. A lot of times those are transport events from out of state. So you can see one here in mid-August, and then you can see another one here late August, September. And then of course, you know, there are local fires that affect regional areas as opposed to the whole area of the state. Okay, so we try to quantify our emissions every year because we're responsible for regulating those. And you can see 2021 was you know, an average year, maybe a little to the low side. See big years like 2012 and 2015, it really fluctuates a lot. But if you look at 2017 from just the emissions point of view, it doesn't look like a really big year. But if you look at it from an air quality point of view, 2017 was a really bad year. And that was because the gap is from transport from out of state. Okay, so we didn't have a ton of our own fires, but we got a lot of smoke from mega fires in Washington, Oregon, and California, like we typically do. So one question I'd like to sort of put out there to all these smart satellite people is, how can we use satellite data to quantify this smoke transport? I'd really like to get a handle on that, you know, maybe some sort of ratio of total AOD to PM 2.5 emissions or something, you know, and a higher ratio would mean a bigger transport year, something like that. It's, I haven't, something I've been wrestling with, and I would like to throw it out there. Okay, to switch over to exceptional events. This is a big part of our work. I have recently started calling it tilting at windmills because it's become an increasingly futile endeavor. Tom pointed this out, and I'm going to point it out again, that wildfires are by far our largest source of PM 2.5, carbon monoxide, and VOCs. If you see this chart in blue, we've got 2021 wildfires emissions, and we're comparing it to the major categories from the 2017 NEI. And so the NEI data is full year statewide, and the 2021 wildfires are just for the third quarter, basically, July, August, September. And note it's a log scale. So these wildfire emissions far outstrip any sort of industrial or mobile emissions we have. And if you look at NOx, you know, as I stated, 2021 wasn't a really big year, but if we do have a big wildfire year, our NOx will outstrip mobile and industrial sources.
Hey, Sarah, if we could wrap up, we're just running a little low on time. Thank you.
Okay, yep, I think this is my last slide. Oh, it's 2 months. Anyway, we screen every quarter. So after Q3 this year, this slide up in the right, 91 total days in the quarter, 75 of which were flagged, and we screened and found that there was evidence to support an exceptional event. And so that's basically most days in the quarter. And it really causes a lot of cognitive dissonance, because that's not exceptional, it's every day. So smoke impacts most days every summer. Exceptional events allow us to excuse these days. So we spend a lot of time screening, writing demonstrations to basically explain away our largest source. And we would actually rather be focused on figuring out solutions to the wildfire problem rather than excusing them. But that said, I use HMS smoke polygons, high split back trajectories in screening. I've written a lot of PM 2.5 demonstrations over the years. I've used HMS smoke and fire detects, MODIS and VIIRS imagery, VIIRS AOD, and I'm interested in using the Sentinel-5 aerosol layer height in the future. I think that will add a good piece of evidence. So that's it for me. Thanks.
Great. Thank you so much, Sarah. And thank you to all of our speakers. We're excited to move now into the open discussion session. So great. Thank you, panelists, for turning your cameras back on. And so I'd like to open with a first question that was submitted from Ira Domsky at the Maricopa County Air Quality Department in Arizona. And Ira's asking, Jingqiu, could you address the vertical profile of smoke and how the use of CMAQ allows you to improve the correlation between AOD and the measured surface PM 2.5?
Sure, thanks. Happy to do that. So we have been looking at the vertical profiles of aerosol from Calypso as well as in the model. They tend to disagree. So which could be part of the reason the model derived a slope of AOD versus a PM 2.5 slope is too high. We saw that could be part of the reason for that. We intend to do some correction, but this is still something we have not fully developed yet. But there is a discrepancy on a vertical distribution of aerosols between model and observations. For your second question, that for CMAQ, that is, I should refer this to Jessie, who has actually did most work with her paper published. That is just one member of this ensemble that, you know, any model simulation can be included for this ensemble model forecast. It's just one member. I think further details you might want to ask Jessie, who I could send you the details of her information as well as the papers. I think that paper has a lot more details. I'm not quite expert. I'll be honest with you. I'm not quite expert on that particular topic. So it is very helpful. I don't know if I answer your question. Please feel free to let me know if you need more information on that.
Great, thank you so much. I think we'll move next to a question that I think it would be great to open to Tom and Sara first, and then if others want to weigh in as well. I think in Tom's talk, it was clear that there are these different frameworks for ozone and PM. And so sometimes they overlap and sometimes they don't. And so, and Sara brought up this question that I think, Jeff was commenting on here about, what really is an exceptional event, and was the intention that exceptions should be made every time there's wildfire smoke, or was it in its sort of intended policy sort of framing originally as these events are supposed to not be happening so often such that they are rare, right? A statistical sense of it, exceptional. And so I think it would be great to hear more about, I guess, your experience with navigating these different types of frameworks. And I guess maybe a more specific way of asking this question is, when you are filing an exceptional event demonstration, can you write one document for ozone and PM, or do they have to be separate? And is the daily PM different from annual PM? And anyways, I'll stop there, but hopefully we can get some discussion going on this challenging topic of this intersection of fires and the air quality policy. And of course, from a health perspective that I think Sara was bringing up that we don't want to lose is, people are being exposed to this smoke. And so how do we handle all of that?
I guess I can start. I guess sort of in answer to Jeff, yeah, no, I've always thought of it more as definition, meaning as outlier as opposed to exception. I mean, I think the rule is unintended consequences of this rule, like, yeah, nobody expected that, wildfires would get so bad and that we'd have to write off an entire summer every summer. But like for dust events, because that's also in the exceptional event rule in Idaho, we've written a couple of those, and those are just sort of rare one-off events that really seem to make sense and it's not something we can control either. But I think in, say, a place like New Mexico, where that's just a seasonal part of life, they get a lot of dust, they probably feel like we do about wildfire exceptional events.
Thanks, Tom. It would be great to hear your perspective too.
Thanks, Arlene. I'll try and add on to what Sara said, and I don't mean to put her or her agency on the spot, but with respect to the exceptional events rule, it refers to events not expected to routinely recur. So the nature of the event is to be exceptional, or at least non-recurring on some reasonable basis. But sort of below, so this is we're on the Titanic, and there's a piece of ice sticking out of the ocean, but underneath the ocean is a lot of ice. And it's and so metaphorically, fire is going to be with us for decades at this level. That's the reality that we're living in with a warming climate, fuels accumulating, that sort of thing. So when Idaho DEQ is talking to people as smoke is being transported into Idaho, as fires are occurring in Idaho, and as Sara said, those are not necessarily coincident every year. Sometimes it's local, sometimes it's more distant, sometimes it's both. We had a giant fire year, as Jeff said, in 2020 in Colorado. We had local fires, we had regional transport. 2021 was the exact opposite of that. We had only regional transport, but the air quality was terrible. I mean, we got like a funnel going that just dropped into the urban part of the Front Range. But if you're a state air agency and you're telling people the air is bad and here's your strategies, to deal with it, then the point that Sara and I think are making the same point is when you try and explain later that those data points don't matter, is a little bit of a disconnect. And from a regulatory point of view, non-attainment issues, it makes sense the way the rule was constructed. But we've been living with a great deal of fire activity in the West since the Yellowstone fires. There was about a 70-year hiatus between the Big Burn in the early 1900s and the Yellowstone fires. And if you look at the record, there's a lot of wildfire since 1988 in the West. It's just that the standards weren't as tight as they are now. So as we've cleaned up the air for other reasons, fire becomes more of a contributor. And we see health impacts from the HAQAST review at lower and lower levels. That's why maybe we're most concerned, Arlene, about, if the PM or the ozone standard were made more stringent, what do these data mean for determining the status of these areas? Because we've never had regional non-attainment in the West like the East has been working through. And this is an uncontrollable source. I mean, there's mitigation, as Sara said, but it's uncontrolled.
Great, thank you. Well, this is generating a lot of follow-on discussion questions here. So let me try to see if we can summarize and address them. So Mary Yule put in a comment that asks about touching on the regulatory significance and exceptional events. So I don't know if there was anything else, Tom, that you wanted to add with respect to your previous.
Well, there's real quick. I'll try and be brief. Real quickly, there are the concept of the rule is this regulatory significance, and I breezed over it. Non-attainment, not getting more serious, not maintenance areas, not getting bumped up to non-attainment, and preventing areas from going into non-attainment from these uncontrollable sources. Those are the framework for regulatory significance. But as Daniel said in the comments, people are breathing this air, and the states and federal agencies are advising people during the fires that it's unhealthy to one degree or another. So if the collectors of the data, the states, locals, they have to do these demonstrations. You can do a regional analysis, you can provide technical support. Maybe Sara and I kind of function in the same way. We provide technical support to people who have to make policy documents. And so it's not really clear what you do for this always recurring, long-term, ongoing situation that's not exceptional. That's where the disconnect comes in, and maybe there needs to be a modification to what the rule tries to address. So I'll stop rambling.
Okay, and actually maybe quite before you stop, Sara, this may be more for Sara, but maybe also for you, Tom. Matt Hollinger, and I apologize if I'm mispronouncing people's names. I'm trying to give credit to questions, but I apologize if I'm mispronouncing names here. Has it become increasingly more difficult to obtain EPA concurrence on exceptional event demonstrations over the years from the implementation of the 2016 exceptional event rule?
I would say no. Yeah, no, I mean, I've been doing them since 2012, and it's sort of the first one's the hardest. And after that, you sort of get a sort of outline going, and no, yeah.
Okay.
Yeah.
Okay. So, and actually, while you're speaking, Sara, I'm going to ask you to comment on Kevin Cromar's question, which is basically asking if some centralized processing of exceptional events might be a potential solution for addressing the time management issues you raised about state air agencies having to spend a non-trivial portion of your time putting together these demonstrations, for instance, rather than planning and mitigation. And Kevin asks if centralizing some sort of processing would be helpful, or if there's other solutions that have come to mind that might take some of the burden off that a state or local air quality management district is facing in implementing the exceptional event rule.
Yeah, definitely. I definitely think some sort of centralized way to do it would take some of the burdens off the states. We've tried to cooperate with other state agencies before. We shared a conceptual, our conceptual model on I think it was 2017 demonstration with the state of Washington, because they were writing one for their days. The only problem is like parts, the way the rule is written is that parts can be done together, but then you always have to, document for your own sites, your own monitors, very specifically. You have to make a clear causal relationship. So the way it's written, it's like, it's hard to do it centralized, or at least all of it. It's difficult.
So there's some nuances built into that. Does that mean a federal program to do that work? And that would require each state to interact with that federal program to deal with the specifics that Sara was alluding to. How would academia, fit into that? Is there a way to research and publish to such a centralized program? Are the regional differences enough that trying to do a US-wide program doesn't really make any sense? There's a lot of nuance there, and I hate to say it, but it's all about the resources. How do you find the resources to respond to this ongoing issue?
Thank you, Tom. I think these are definitely points that will give all of us food for thought. And so I think I do, in the interest of time, want to try to address a couple questions in different lines, but I would encourage everybody. I know the virtual format makes it a little more challenging, but hopefully in some of the coffee breaks, et cetera, we can move forward. I see that Jeff has his hand up, so go ahead, Jeff.
Thanks. Hopefully this mic works better. I just thought I wanted, Sara proposed a question in her talk about how to assess transport. Would it be possible for us to discuss this now?
Sure. Yes. Let's go that route.
I like your starting point there, Sara, for looking at the ratio of AOD to your quantified emissions. My only concern is I don't know what, I know at least some fraction of the time when smoke is transported to Idaho, it's in the free troposphere and not at the surface, in which case you'd have AOD, but it wouldn't be regulatory relevant. And then sometimes you have emissions of your own fires that probably don't go where the monitors are. So I don't know if using PM 2.5 monitors, the whole thing was really hard without models, but then the models have issues with where they inject the smoke as well. So I think like hybrid approaches like Jingqiu was showing, or maybe like that sort of thing of models plus AOD and those things, and having to do multiple simulations and turning off your own emissions and looking at how much smoke still comes and those sorts of things might be a way to do it. But it's a super challenging problem that I think you're not alone worrying about.
Thanks. And Jeff, sort of along those lines, I did want to just sort of, what can we see from space? How do we know where vertically these sources or the smoke from sources that's being transported? Sorry, I've lost my grammar, is or are. Sara Farrell had raised a question for Jingqiu, but I think it could also go to Jeff or others. First of all, she says, thank you for your presentation, Dr. Mao. And would a Modus AOD fusion product be appropriate to use for detecting PM 2.5 concentrations from residential wood combustion during the wintertime? So it's a little bit broad, but I think it's a related point of what's detectable from space. How can we get the information that's really needed on the ground? So I'll stop and let you, Jeff and Jingqiu, comment.
Jingqiu, why don't you go ahead if you.
Okay, thanks, Jeff. Sara, thanks for a great question. This actually is a major concern. I should mention that Fairbanks is one of the most polluted cities in the United States. And I think 2018, we were ranked at #1 most polluted city in the United States or in North America. So the main reason is because of residential heating, wood burning. We have very shallow boundary layer that often like 20 to 30 meters high. So there are a lot of challenges on using satellite to detect wildfire in winter. First of all, we have lots of snow on ground that really largely changes the surface albedo. This is actually a major challenge for space observations. Another main challenge I should mention, because it's in Fairbanks, where I'm living, maybe it's not quite a problem for lower 48, is that it's pretty dark here in winter. So you do not have many photons to start with. And satellite just, if you're using UV or visible satellite, it's just hard. It would be best to use some infrared, or you're using some city lights as a light source. I know Professor Jun Wang and Jesse, their group have been using some city lights as a source to detect this PM 2.5 space for nighttime PM 2.5. That's a different topic. It's very hard to do that, particularly think about if the inversion layer is like 20, 30 meters high with snow on surface. That's just, I haven't seen any work being done yet. This might be something would be worth thinking of, but I would also just say this could be a challenge. Maybe we need some smart people to think about, help us with that. I just should mention one more thing is actually we're organizing a field campaign to study air pollution in Fairbanks right now. We have like 40 chemists here right now. So that's why I'm kind of slow this morning. Sorry about that. Okay, Jeff, please go ahead.
No, I think what you do is great. I know Tom wants to speak on something and we're almost out of time, so let's go to him.
Oh, thank you, Jeff. I didn't mean to take away from you. I noticed there was a question and comment about the intersection between prescribed fire or planned burning and the wildfire phenomena that we've been discussing. So prescribed fire is not really in the Clean Air Act. It's something the states and federal land managers in particular have developed unique programs in almost every state. Certainly states learn from each other. That's one of the functions of Westar RAP is to bring people together to talk about how those programs work, and we're going to keep doing that. But if you kind of step back and you look at this in soft focus, and the wildfire season in California, for example, might run 11 to 11 and a half months a year. You might find a couple of weeks when there's not a wildfire possibility or one going on. So one of the challenges is a prescribed fire is supposed to, reduce fuel loading in a structured way. So how would you implement that given the scope and size of wildfire as it's out there? And also the same folks who are responding to wildfires, whether they be at state or federal agencies, also have to get involved in the decision about prescribed fires. So, and the execution thereof. So again, we have kind of human resource limitations there, and there's a lot of working out to do, and California is a leader in how to think about implementing more prescribed fire. So I'm sorry, I'm rambling on here. I'll stop. I'm watching the dialogue here. So
that's great. Thank you so much, Tom. And I appreciate that it is, well, I'm in the East Coast, so it's 1 o'clock, but it's, whatever time it is in the time district or time zone that you're joining from. So I do, obviously folks can sign off if they want, but if the panelists are willing, we can keep this going maybe another few minutes. Oops, there's my alarm to make sure I didn't lose track of time. And so I guess everyone okay to stay for like maybe just 3 or 4 more minutes. Tom, I didn't know if you actually raised your hand because you wanted to comment on some of the earlier discussion. So let me give you that chance first.
Well, Jeff and I have been doing a little dialogue about chemical transport models. I recognize all their weaknesses, but they have a great many strengths. And so I'd like to think about the work of the HAQAST Tiger teams and looking for that integration between ground-based observations, satellite sensing, and chemical transport models, and sort of clearly identify how those are being put together, because the CTMs are wrong but useful. So how do we come out with results that help identify where the exceptional events and the health exposure is really going with wildfire?
Great, thank you. So there are a few more questions popping up. So I think we'll try to get through as many of those as we can in the next few minutes. Let me see.
Yeah, before we go through that, I just want to make a very quick announcement for anyone that's stepping by. This is amazing, by the way, the amount of questions that are coming through. Amazing first panel to start. Our next panel is going to be at 2 p.m. CST. You can either join Zoom A or Zoom B, and there'll be two different ones. But we'll keep going on with questions as long as we would like to go. And yeah, if anyone's tuning out, thank you so much for joining. But we'll keep answering questions here for a couple more minutes.
Great, thank you. Okay, so I think related to this question of CTMs, satellite data, and ground-based monitors, we have a question asking about, given that population centers in the US do tend to have ground monitoring systems, how do you see satellite data contributing to monitoring and forecasting in these areas? I was going to say, maybe I can jump in from the forecasting perspective and just say that, you know, the initial conditions matter for your forecast. And so if you're bringing in additional information, even though what we have from space is typically the aerosol optical depth, and we've talked through what some of the shortcomings there can be in terms of the vertical distribution, I think that's a real strength, although I should really let our panelists speak. Go ahead, Jeff.
Yeah, no, I mean, it's a great question. And I don't know if my mic was working or not at the time, but one of the examples I gave was there's a lot of times in Fort Collins during the Cameron Peak fire where the city was split in terms of half of the city being in smoke, half of it not being in smoke. And we have one regulatory monitor in Fort Collins for PM 2.5. And my wife would be like, we can't go outside now because like that regulatory monitor was linked to her iPhone. And I'm like, no, we can. Like, I'm looking at the GOES images right now, and I'm looking at purple air and these sorts of things. So I think satellites really can help us extrapolate away from the regulatory monitors. If you're in a really big city, there's a lot, but if you're in a mid-size or small city, you probably just have one regulatory monitor. So the satellites really help you assess away, and smoke can very often, particularly if you're close to the source, it's hyper local. Once it gets transported, it becomes more regional, but often you have really strong gradients near the source.
Great. And I'll thank Tom for answering one of the questions in the Q&A box. So please look at that if you're interested in the question that was posed that may have disappeared from your screen. And let's go back to this question from Malcolm Zachariah from Oklahoma DEQ. I joined very late, so maybe this was addressed earlier. One general thing that would help my state, Oklahoma, with exceptional events is easily recreating output files of satellite imagery, so animated GIFs, etc. Things like the GOES imagery viewer and I don't know how to pronounce this, but RAM-MB slider from Colorado State. So far, we've not needed to do a demonstration yet. Okay, so I think that's a really useful comment, and actually, as you know, sort of the HAQAST team, but also all the other scientists on this is really helpful information to have, because usually what we're trying to figure out is how can those of us on the science side be doing things that are most useful for those of you who are on the ground, trying to use information, often in high stress, quick decision-making type environments. And Jeff, please go ahead.
Yeah, I think the geostationary satellites, particularly for regions like Oklahoma, you probably weren't on when I showed it, but I showed this animation that included some of Oklahoma and Kansas. There's this, during the agricultural fire season and the rangeland fire season there, the diurnal cycle of smoke is really strong. And often the concentrations are not near monitors, not near regulatory monitors. And so having things like RAM Slider, and I use Aerosol Watch a lot, and then being able to get those products and then incorporate them into your thinking. You know, being able to look at the late afternoon just before sunset, which might be really different than some of the polar orbiting overpass times where the fire might not have really, the smoke might not have really kicked up yet. It can be really useful. So yeah, I think the tools you gave are really good. And then there are some other ways that if you need to quantify it with numbers, there's ways to download those. And if you reach out to me, if you want help with that.
Okay. Jeff, I'm seeing there's a question for you while you're speaking. Can you comment some more on the Plains and Mississippi River Valley agricultural and rangeland level of smoke production versus what is transported from further west?
That's a great question that I don't have a good answer to, Tom. So if you're able to make the session 3B on agricultural smoke, Cheryl and Amber and others are going to be talking about that. We have a field campaign coming up in the next couple of months where we're deploying extra monitors in addition to really digging into the satellite data to try to understand that. I suspect they're pretty different times of year in terms of when the Western fires are hitting there. And I think in the area we're looking, the peak fires seem to be in late winter and spring, but there are other times where there's burning as well. And so in that sense, you know, we might be able to decouple the overall influence, at least on the annual totals, by decoupling the seasons for PM 2.5.
Great, thank you so much. So I see that there is another question from Matt Hollinger. I'm wondering, Jingqiu or Jeff or any of the other panelists, if you might be able to try to answer that through the chat so that we'll have it in the answered section. And then I just wanted to read out a comment we received from Michael Geigert at Connecticut DEEP that they had a high PM 2.5 event in Connecticut on July 26th and 27th from Western wildfires. GOES 16 was critical for tracking this, but the HRRR, which is the really high resolution wind field product, smoke product, was wrong about the plume. It was the first time we had to issue a nowcast smoke warning for Connecticut. Levels reached 150 micrograms per meter cubed. And so just again, speaking to the importance of having these geostationary satellite data that can help track the movement of smoke. Again, there's always the question of how much of that gets to the surface. But thank you so much for that comment, Michael. And I think with that, we will close out our session. Thank you so much to our panelists for the really thought-provoking talks, and thanks to our audience for being super engaged and staying on, so many of you, for us running 10 minutes over, and for bearing with our still, you know, slightly glitchy Zoom interface. We're so looking forward to being able to interact in person again, hopefully this spring. So thank you so much, everyone, for a great, interesting session. I certainly learned a lot.